Okay, we're going to be evaluating fractional exponents, okay? So, the first one we have is the fraction 3 over 4 to the power of 3. And there's quite a few ways we can kind of work this out, okay? One of the ways, in the simplest way, is think of this fraction as the base of the exponent and the 3 as the exponent ourselves, okay? And whenever the exponent is a number, it's just telling us to multiply the base that many times. So in our case, because the base is to the power of 3, what that means is when we rewrite it, it would be the base times itself 3 times. So base times base times base. Okay? So by that idea, what that means is we say 3 over 4 times 3 over 4 times 3 over 4. Okay? And then we go to evaluate. So when we evaluate, how do I do 3 at once? Well, I just do a pair. One pair at a time and then multiply the next. So when multiplying fractions, we do the top by the top and the bottom by the bottom, right? We multiply those. So what's 3 times 3?
9.
9. So I'm going to just make a new fraction here. 9 over, what's 4 times 4?
16.
Over 16. So my new fraction, those together are 9 over 16. Okay? And because I still have to multiply it by this, and really, actually, let's write it nicer so we don't get confused here. Because we've done that step, let's rewrite this nicely for ourselves. So now we have 9 over 16, right? That's what that pairing was equal to. That pairing is 9 over 16 times 3 over 4. Okay? So top by the top, bottom by the bottom. What's 9 times 3?
27.
Yeah. And how about 16 by 4?
64.
That's right, good. 27 over 64. So 3 over 4 to the power of 3 is 27 over 64. Now, there's another way I could have done this. 3 over 4 to the power of 3. Now, have you guys done a power of a power yet? The exponent laws?
I did it with Stephanie but a while ago.
Okay, so it looks something like this. Let's say we have like x to the power of 2 and then to the power of 3. What we do there is we take the base, x stays the same, and we just multiply the two powers, 2 times 3. Okay? Well, in this case, what's technically 3 and 4? What powers are they to right now? There's nothing written there.
They're to 1.
Yeah, to the power of 1. So let's rewrite it like that. And you'll notice this looks very similar to the power of the power question. Okay? And all of this is to the power of 3. Well, we bring that 3 in and we multiply it by both those powers. So now it says 3 times to the power of 1 times 3 over 4 to the power of 1 times 3 again. What's 1 times 3?
3.
Yeah, so 3 to the power of 3, 4 to the power of 4. Okay? So 3 to the power of 3 in expanded form. How do I write that? That would be what?
3 times 3 times 3.
Yeah. And where have we already done that?
Right there.
Yeah. So what's 3 times 3 times 3?
27.
You know it's 27. Yep. And what's 4? I shouldn't have wrote to the 4. It's to the 3. Let's fix that. What's 4 to the power of 3?
64.
That's right. So you got the exact same answer, right? So whether we wrote them like exponents like this, or we expanded it by fractions and multiplied our fractions, we got the same answer both times. Does that make sense? Okay, so let's do one a little harder. And by a little harder, I mean now it's a little harder. So now it's a negative fraction, okay? So the thing with fractions is, where is the negative with a fraction? I never know. Is it on the top, or is it on the bottom? Or is it of the fraction itself? What I have to figure out first is, what is a fraction? What does that line in between represent?
Division.
Okay, so say we're dividing negative 2 divided by 3. This is a negative divided by a positive. What will our answer be?
A negative.
It'll be a negative. So really this negative, think of it as applied to the entire fraction. The entire fraction is a negative value. Now, it actually doesn't matter if I say, excuse me, if I say that this is negative 2 over 3, or I say it's 2 over negative 3 to the power of 5. I'm still going to get the exact same answer. Okay? There makes no difference. In terms of adding and subtracting, just to be consistent, it would be easiest if we kind of keep the negative on top. Okay? And if you add and subtract and think about it, you'll understand why after. Okay? But anyways, let's keep it as on top, as if it's applied to the negative 2. Okay? So what does this mean? What do I have to do with this fraction if it's to the power of 5?
Yeah, it's multiply 3 times 3 times 3 5 times.
Yeah, 3 to the power of 5. And what about negative 2?
2 to the power. Negative 2 to the power of 5.
That's right. So there's two ways I can write this, right? I can write it as negative 2 over 3 5 times, right? Write it 5 times over. Or I can say that this is the negative 2 to the power of what?
Oh, 5.
Yeah, over 3 to the power of
5.
That's right. Both are acceptable, right? And let's say we do this. Let's bring out our calculator. So 2 when it's negative to the power of 5. Now here's my question to you. Okay, I gotta hit equals. When I multiply negative 2 5 times, will it be positive or negative?
Negative.
How do you know that?
Because you're wait. No, it would be no, it's negative.
How do you know that?
Because you're multiplying negative by a negative, but it's an odd amount of times.
Yes, that's right. Because it's an odd exponent, you end up with a negative answer. So here we go. Negative 32. Okay, so we have negative 32, right? And what is 3 to the power of 5? Well, I don't know off the top of my head, so I'll put it in here. We could write it out, but this is a nice fast way. 243 over 243. And you've noticed the negative still stayed. It's still a negative divided by a positive, so really it's a negative fraction in the end, right? How's that? Make sense for evaluating?
Mm.
Okay.